Welcome back to part 5 on rational functions. We need to sketch the graph of the functions listed here, and we also need to state the domain and range. The domain of all these functions is based off of the restrictions in the denominator. So our first step is to factor the numerator and denominator. The numerator is already factored, it's just 3 times x. The denominator is x times x minus 2, which means that there are 2 vertical asymptotes in the denominator. There's a vertical asymptote at x equals 0 and a vertical asymptote at x equals 2. So the domain of this function is from negative infinity to 0, union 0 to 2, union 2 to infinity. The range of this function is based off of whether we have any horizontal asymptotes. Since the degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote at y equals 0. So our range is from negative infinity to 0, union 0 to infinity. Our next step is to reduce the numerator with the denominator if possible and find the holes on the graph. In our case, we have a common factor of x that will reduce out of both the numerator and denominator. So my holes in the graph will be when f of 0 happens. And if I've reduced the x out, I will be left with 3 over x minus 2. Substituting the 0 in for x, I will have 0 minus 2. This will give me negative 3/2. So there is a hole at 0, negative 3/2. Like the previous example, instead of a vertical asymptote, as I initially assumed, I now just have a hole at that coordinate point, and the vertical asymptote no longer exists because I divided out the factor x. So now I need to determine what my other asymptotes are, if any exist, and I've already found a horizontal asymptote at y equals 0 along the x-axis. My remaining vertical asymptote is at x equals 2, and so I'll move on to step 4. Find out if your graph crosses the horizontal asymptote. If so, where? We can find out if it crosses the horizontal asymptote by setting the remaining function equal to y equals 0. 3 over x minus 2 equals 0. That means that 3 equals 0. If we multiply both sides by x minus 2, and that is not a true statement. Since this is not a true statement, there is no point at which the graph crosses the horizontal asymptote. No crosses on y equals 0. Now if you have enough to work with, sketch the graph. We also need to remember that if you have a horizontal asymptote, create a sign chart and use that to graph. So now that we have all this information, let's see what we can do here. So I have a hole at 0, negative 3/2. 2 will be my other vertical asymptote. I have a horizontal asymptote along the x-axis. The function never crosses, and so now I can just pick values to the left and to the right of the vertical asymptote. This will tell me where my function is above and where it is below. So I'll pick 3 as my test value, and I'll pick 1 as another test value. Substituting 3 into f of x gives me 3 over 3 minus 2. This gives me a positive final output. So I know the function is positive anywhere to the right of the vertical asymptote. Now let's take a look at f of 1. This will give me negative values. So anything to the left of the vertical asymptote is a negative. The trend is for the curve to cross this removable discontinuity. I also know that the values are negative to the left of the vertical asymptote and positive to the right of the vertical asymptote. So now I will sketch the graph. It's going to hug the asymptotes toward infinity. So the curve of the rational function must stay positive but approach the vertical and horizontal asymptotes.